going to be looking at logarithms today and what a logarithm is and logarithmic functions. So we want you to be able to evaluate a logarithmic expression, that you can solve a logarithmic equation, and also that you can solve a logarithmic inequalities. Remember, inequalities are when you have less than, greater than type symbols. All right, so first consider the graph of y equals 2 to the x and its inverse. Okay, so 2 to the x, that's an exponential equation. We've looked at exponential equations before. You get one of these growth equations, or you could also have an exponential decay equation, but this one's growth since 2 is a number bigger than 1. And since an exponential functions are 1 to 1, that means the inverse of 2 to the x is also a function. And that would be this red graph right here. Okay, remember you get inverses by solving for the other variable. So if we got this as a x equals equation, x equals 2 to the y, that's what the graph is down here. And when you switch the x and y and you graph that, you get this graph. And this graph is what's called a logarithm. Okay, the inverse of a exponential is called a logarithm. And that's the type of graph you get. And what that looks like when you switch them around is what's called a log. So when you switch around the x and y and you solve it, you get this right here. Y equals log base b to the x power. So when you're doing logarithms, this is the opposite or inverse of this. So we want you to be able to switch back and forth when doing these types of problems. Okay, so what you're looking at when you do this is that base number, okay, is the same on both. This b right here, okay, is the same as this b right here. So whatever your base of your exponent is, okay, this is the base of our exponential, becomes the base of the logarithm. Okay, whatever you're taking, whatever this logarithm's equal to becomes your becomes your value still equal to it on this one, and then your x becomes your exponent. All right, let's try some of these out here. So in number 1, we want to figure out what is this equal to. Okay, and they're saying it's equal to 0. So we want to show that this is in fact true, that this logarithm makes sense. So we're going to change from log form to exponential form. So in logarithmic form, which is listed here, we got this base number of 8. In exponential form, 8 is going to be the base of our exponential. Okay, whatever this log is equal to just stays where it's at. So the only number left that we haven't used yet is 0. That becomes our power or exponent. So as an exponential function, that's what this one looks like. Okay, now you can test to see if you did it right or not. So do these two sides equal each other? Well, let's see. 8 to the 0 power. If you do anything to the 0 power, that's equal to 1. So are both sides equal to each other? Yep, this one was right. This is the exponential form of this problem. All right, let's try another one here. Okay, in this one, we want to, again, write this as an exponential. So whatever you're taking the log of just stays where it's at. Okay, the base number, that's our base, it's going to become the base of our exponential, so 2. The only number left then is this -4, that becomes your power or exponent. So is this the same thing? I think it is. Remember, if we have negative exponents like we do on this right-hand side here, another way we can write that would be to move it to the other side of the fraction, in this case the bottom, and that becomes positive. And then 2 to the 4th power, if you do 2 to the 4th power in your calculator, 2 times 2 times 2 times 2, that does equal 16. So yes, this does in fact check out. That would be the exponential form of this problem. All right, let's try one more of those. Why don't you guys pause the video here, see if you can try C out and see what you get. All right, let's see how you did on this one. What you're taking the log of stays in the same spot. Your base becomes the base of the exponential. The only number left is 2 here. That becomes the power. So is 16 equal to 4 squared? Yeah, it definitely is. That's the exponential form. Okay, the next problems are kind of doing the exact opposite of what we just did. Now this is in exponential form. They want us to write it in logarithmic form. Okay, so when we're writing it in logarithmic form, whatever we're taking, the log of is going to stay in the same spot. So here, we're going to be doing log of 1,000. Okay, our base of our exponential is 10. That's our base. That means that needs to become the base of our log, and that means this is going to be equal to whatever number's left here, our exponent 3. So that's how we would write that in logarithmic form. Let's try another one of those. So on B, okay, we want to write this out again. Whatever we're taking the log of is going to stay on the same side. Our base on this one is 9 because that's the base of the exponential. So that is going to be our base number. And then the exponent is what it's going to be equal to. All right, there's one more here. Again, why don't you pause the video, see if you can try C. What would this one be in logarithmic form? All right, let's test it out, see how you did. If you did this one correctly, you got log, our base number is 125 of 5 should equal 1/3. Okay, now when you are doing these, there is a way to test to see if you did it correct on your calculator or not. The way you can do these on your calculator is if you go to your math menu and you go down all the way down, you should have one that says log base. You can then type in and see if in fact is this correct or not. So if we type in base and our base on this one happened to be 125, then hit your over key and it'll jump up to this parentheses, hit 5. If we did this one correct and we hit enter, it should give us 1/3. And we get 0.333333, which if you hit your math fraction button is equivalent to 1/3. So yes, we did this one right. Okay, TI Inspire, if you just hit your regular log button, will do the same thing, let you enter the base and the number. If you have a TI 30, kind of that smaller scientific calculator, you don't have the ability to do that. We'll show you on the next example a way you can check though on your calculator with that one. Okay, so these next problems, they do want us to now evaluate and see what is this equal to, okay, on A. So for A here, they want us to know what is log base 2 of 64 equal to. Well, how you can do that on this problem is one, use your calculator. So we could do the same thing we just did. Hit math, find that log base, and you can just type it in 2, and we can type in 64. And you can hit enter, and it looks like the y in this case equals 6. Okay, so that would be one way to do it. Use your calculator and you can test it. Another way that you can do it if you aren't able to use your calculator is do what we did before. Change it to exponential form. So if we wrote this problem in exponential form, it would be that 64 equals 2 to the y power. So now what you would have to figure out, okay, is 2 to what power is going to be 64? Well, if you go on your calculator, you should be able to test out and see what power of 2 that's going to be. So let's try 2 to some powers. Let's try 2 to the, I don't know, let's try 4th power. No, 16. If we try 2 to the 5th power, you get 32. Let's try 2 to the 6th power, and I think we're going to have a good result here. 2 to the 6th power is 64. Okay, that's why our answer ended up being 6 here. Okay, because 2 to the 6th power is 64. So what does y have to be here? Y is 6. So if you don't have a calculator that can do that, then you'd have to, you're going to have to kind of guess and check. There will be a way that we'll learn later in a couple sections of a way you can do that with your calculator, doing some solving once we get into logarithmic properties. All right, let's try another one of those. Okay, so this one, again, you could use your calculator to evaluate. So you can enter log base 3, make sure you hit over then to get up to your parentheses, type in 81, and we see that answer is 4. Y equals 4. Okay, now if you don't have a calculator, you're going to have to change to exponential form. 81 equals 3 to what power? So what power of 3 is going to make this equal 81? Well, we know it's not 3 squared. 3 squared would be 9. If you keep going and end up trying 3 to the 4th power, because that's what the answer came out to be here for, you would see that, yep, 3 to the 4th power is 81. So that would tell you y is 4. All right, why don't you guys, again, pause the video here, try out C, and see what you come up with for that problem. All right, let's see if you did it correctly here. You should have also come up with an answer of 4 on this one. You can use your calculator to do it. If you change it to exponential form, you get that 256 equals 4 to what power of y here? And if you keep trying, eventually if you figure out 4 to the 4th power is the same as 256. So the answer is 4. All right, looking at logarithms, these are some properties that you should know, and these are ones that talk about properties of logarithms. So logarithms are functions that are continuous and they're one-to-one. That means one-to-one means there's an inverse of them. We already talked and showed you the inverse is an exponential graph. The domain is the set of all positive real numbers, and that's an important one. Let's go back and look at the graph of this logarithm right here. Okay, this red graph. This red graph, if you notice, it's going to keep going this way to all the positive x's, but let's look at the left side. What's the left side do? Here's the y-axis right here. You can see that our graph never crosses or hits that y-axis. It just keeps getting closer and closer and closer to it on this left side. So that means that you cannot take the logarithm of 0 or take the logarithm of a negative number. It doesn't work, okay? Just to show you, let's go on the calculator and try some. So if you go on your calculator, there's a log button over here. Let's hit log of 0 and see what happens. No, domain error. You can't do log of 0. Also, watch what happens when you do log of any negative number. Type in any negative number. I'll do log of -2. You also get an error because negative numbers and 0 are not on the graph, so that means they're not in the domain of logs. So keep that in mind. The reason is that the y-axis is an asymptote. Asymptote means that the graph doesn't touch it, it just gets close to it. The range, remember that's the y values, is the set of all numbers. Because on the graph, again, if we look, the graph keeps going down here to all the negative infinity. This side keeps going up to positive infinity, so all the y values eventually are in this graph. Okay, and then the last one, the graph contains the point 1, 0. The x-intercept is 1, so that's another property there. All right, so we're going to solve some logarithmic equations out. We're going to do the same thing we were doing before. You got to be able to change from log form to exponential form if you can't just type this in your calculator. And this one we can, since n is in there. You can't do it with n, we need numbers. So if you see a problem like this, you're going to need to change. So if we change this to exponential form, it would say n equals, our base is 4. That means this number becomes our exponent. N is going to equal whatever 4 to the 5/2 power is. Now this we can put in our calculator. It's all numbers. So now you just jump on your calculator and type in, okay, what's 4 to the power of 5 divided by 2, or 5 halves, and we see the answer is 32. So then it just becomes a calculator problem once you do that. Let's try another one. B, they want us to find what this one equals. So again, change from log form to exponential form. Whatever you're taking the log of stays in the same spot. Our base number is 9. That's the base of the exponent. That means this last number becomes our power exponent. So now you just got to put in what's 9 to the 3/2 power. If you do that, you should get 27. 27 is the answer. All right, why don't you pause it, try out C, see what you come up with for C. All right, this one's a little bit different than the last two, but you still got to change it to exponential form. In exponential form, you get 121 is equal to b to the second power in exponential form. Okay, now this one, we're not quite done solving yet because we haven't got the variable quite by itself. There's this power 2, but you guys should know how to undo power 2 here. You want to take the square root. So square root of 121. And it should be plus or minus. And square root of 121 is 11. So it looks like there's two answers here of 11 and negative 11. But remember how we talked about, well, actually, yeah, B could be either. So I think on this one, there's two solutions of 11 or negative 11 because we're not taking the log of that number. So there would be two answers to this one. All right. The same thing applies if you're doing inequalities. The only thing you got to remember when doing inequalities is you can't do logs of 0 and you can't do logs of negative. So we got to remember that the domain on all of these, whenever you're doing a problem, the domain is that whatever you're taking the log of has to stay bigger than 0. So we need to include that if applicable in the problem. Okay, so on A here, we want to solve this. Again, we can't type that in our calculator, so change it to exponential form would be x, keep the same symbol, base is 5, that means 2 is our exponent. We get that x is less than 25 here. So that's the answer. However, not every number less than 25 would make this true, because as we start getting to 0 and negatives, that doesn't apply anymore because that's not in the domain. So that means x needs to be less than 25, but it also needs to stay greater than 0. So then what we can do is combine these into a compound statement. X has to be less than 25, but it also needs to stay greater than 0. As long as x is between there, this statement should come out to be true. Let's try another one of those. On this one, change again to exponential form. So whatever you're taking the log of stays there, symbol stays the same, base is 4, that means our exponent is 3, x has to stay greater than 4 to the third power is 64. Now again, our domain says that whatever we're taking the log of x needs to stay greater than 0. But in this problem, we don't need to include that in our answer, because if we're already bigger than 64, that means we're automatically going to be bigger than 0. So we don't need to include this as part of our answer in this one, because if we're bigger than 64, that means we're also going to be bigger than 0. All right, why don't you guys pause it, try C out, see what you can do. All right, if you change this to exponential form, you should get that x has to be less than 2 to the 4th power. 2 to the 4th power is 16. Okay, so it's everything less than 16. This is one, though, where the domain is going to come into play. With domain here has to be, x has to stay greater than 0. We can't do logs of 0, can't do logs of negative. And so this one, you'd want to combine these into a compound statement. X has to be less than 16, but it also needs to stay greater than 0. Any of those numbers make this true. All right, last problems. These are just some solving ones where you're going to be doing some solving with logs. Now, one thing you should know about logs as we go here, if you have the log of the same thing on both sides of the equation, that means you can just drop them out. As long as it has the same base number, you can just cancel them, and what you're left with is the two things you're taking the log of. So if we can just solve this out now, we should be able to solve this problem. All right, well, this one looks like a quadratic since we got power to degree 2 and degree 1 here, we need to get this equal to 0. So next step would be to minus x. So now we got x squared minus x minus 2 equals 0. This looks like one we can factor. What two things multiply to negative 2 and add to negative 1? That looks like minus 2 and plus 1. Now set these both equal to 0, get your solutions. And the two solutions on this one would be 2 and negative 1. Okay, however, you got to check, do both answers work? 2 I think is going to work fine here. Okay, that means we're going to have log 2 on the right side, and 2 squared is 4, 4 minus 2 is 2. We get log 2 equals log 2. This answer checks out, that's legit. Let's look at the other one though. If we put negative 1 in, can we do logs of a negative? No. That answer is not in the domain, so the only answer on this one is 2. So if you get an answer that gives you log of negatives, that's no good. Let's try B. Okay, again, we got log of the same base on both sides. You can drop that out. So you got x squared minus 15 equals 2x. Now if we can solve this, then we got the answer. Again, this one's a quadratic. We're going to need to get everything to the same side. Okay, this one looks like it factors here. Got x and x. What multiplies to negative 15 adds to negative 2? Negative 5 and positive 3. Put them both equal to 0. And solve. And we get answers of 5 and negative 3. 5 does check out. 5 is going to be a good answer here. Negative 3, though, if we put negative 3 in here, we end up getting log of negative 6. We can't do logs of negatives, so that answer does not fall in our domain. The only answer on this one is 5. All right, why don't you pause the video one last time here, try this last one, see what you get. All right, let's see. Logs drop out, so you got x squared minus 30 equals x. Get it equal to 0 by subtracting x. And this one factors to x minus 6 and x plus 5. Put them both equal to 0 and solve it out. And the answers you get are 6 and negative 5. Do both work? No. Can't do log of the negative 1 again. 6 is the only answer on this. All right, try some of them out on the practice, see what you can do.